All right, we're back. We're on page 3, note 16. We're talking about parametric equations. We did some tangent line stuff. We talked about dx dt, dy dt, what those can tell us. You're either moving left and right with dx dt, moving up and down with dy dt. By the way, you can be moving to the left and speeding up, moving to the left and slowing down. You can do those like particle motion problems where you just independently analyze the x coordinate or the y coordinate. That's a possibility. You can talk about when you're not moving at all, right? If you're not moving at all, you need dx dt to equal 0 and dy dt to equal 0. They both have to, because if only dx dt equals 0 and dy dt is positive, that just means you're moving up in a vertical line. If dx dt and dy dt are both positive, it means you're moving up and to the right. So like we get all these combos that we have to like start thinking about and working on. But anyway, this is like practice problems. So given a particle moves along a path such that dx dt is cosine of 2t, dy dt is 3 secant of 2t. And I'm shaking my head because I have no idea what this path would look like. I guess we're going to find out when we do this. All right, we want to find just dy dt. Oh, I see. We're given dx dt and dx dt and dy dx. I may have read that wrong because I definitely didn't mentally read it right, even if I said the words. All right, so I want dy dt. Well, I have dy dx, and that should be dy dt over dx dt. So then dy dt, I think if I hadn't been asked this question, I would have gotten like everything wrong. It should be dy dx times dx dt. Okay. So that's going to be cosine 3 secant of 2t times cosine of 2t. Well, that's nifty. So secant is 1 over cosine. So this is just 3, just straight up 3 all the time. That's interesting. So dy dt is 3. I don't know why I'm so skeptical of that. That's like universally 3. You are always moving up 3 units per second. And then x is moving left and right. So like, what is this? This is just like it's like a weird sine function, I guess. Like a sine function, but sideways. That's like going up and down the y-axis. It's actually just going up the y-axis because it's not going back and forth. Going up the y-axis, going left and right as you do it. That's what I think is happening here. All right, so we got to find x of t and y of t. So we can actually use the fundamental theorem. Like we know several things. We know dx dt is this. We know that x is going to be -3 when t equals 0. So x is going to be the integral of cosine of 2t dt. And then I'm going to like solve for c. So what do we get here? 1/2 sine of 2t plus c. And then I know that at 0, I get -3. -3 is 1/2. The sine of 0 is 0. So c is -3. So x is 1/2 sine of 2t minus 3. And then for y, we do the same thing. So y is going to be the integral of 3, apparently, dt, which is 3t plus c. And then we know that, so dy dt was this. Y is equal to 2. So 2, 3, what? 2? I don't know what I'm saying. 2 equals 3 times 0 plus c. C is 2. All right, so y of t is going to be 3t plus 2. And so the parametric equations, I guess I would write 1/2 sine of 2t minus 3, comma, 3t plus 2. I believe that is correct. And I hope I'm right. But I'm sure everyone's checking, so that'll be good. Get a lot of comments on the mistakes. And like, yeah, I make a lot of mistakes. I'm recording all the notes and I got no one fact checking me as I go. Usually when I'm teaching, I have a lot of people fact checking me. All right. 3 different particles move from point A to point B, shown in the figure below. Sure. The paths they follow are given. So we got 4t, 2t plus 1. So that's a straight line. It's got to be this guy. That's path 1. let's do this. Let's do a highlighting thing. So, picked it up. It's got to be this for sure. And then the next one is 2t, okay, and then a quadratic that opens down, so that's got to be this. And then the next one is 12t, and then like a negative cosine, which would like start at the bottom and go up. So I think this makes sense. Okay, identified. I don't know if we were supposed to do that. For each path, find the time it takes. Okay, so the time it takes. I think the easiest thing is to just deal with x, right? So x is going from 0 to 6. So if x is going from 0 to 6, how long does it take this? Well, I just need to solve for path 1. I need 0, 4t, 6, right? Because the x coordinate is controlled by 4 times t. So for this one, it takes 0, 3 halves. So it takes 3 halves for the first one, the second one. So I chose the x coordinate because the x coordinates were just easier, right? Like, I mean, I could do the y's. I need y to go from 1 to 4, but then I got to figure this out. Not a big deal. But then I got to figure this one out. Bigger deal. Then I got to figure this one out. And I just don't want to do it. Whereas the x's are all linear, all nice and linear. Look for linear things. That's what you want to use. So 2t has to be between 0 and 6. Come on. Why can't I write the thing correctly? I mean, I don't expect anyone to know, but still. Path 3. 12t has to be between 0 and 6. So path 3 is really fast. And you don't get that from the picture, right? You can't tell in the picture that you are necessarily going so much faster. It only takes 1/2 of a second. So path 2 is the slowest. You cover the most distance, right? I mean, that's definitely a longer like arc length, which is something we'll have to talk about for this. That's a longer arc length. And it took longer, but like, you know, you just could have gone faster and farther. That also, I guess, would have been an option. Find dx dt, dy dt, dy dx for each path. Super great. Okay. So we want, I'm gonna do the work here and then move it down. So path 1. dx dt. You should really find dy dt first. dx dt is 4. dy dt is 2. And then dy dx is going to be dy dt over dx dt is 2 over 4. So 1/2. And that makes sense because it's a line, right? This one's definitely linear. And so you go up 2 and you go up 3 and you go over 6. Up 3 over 6, so 1/2. Makes sense. We're moving this down. Hopefully there's enough room. Yeah. Okay. Let's go do path 2. So path 2. So the beginning of parametrics, like all of parametrics is just like a review, really, of like using ideas that you already know in just like 2 dimensions and like linear along an axis, I should say. And now we're allowed to move like anywhere because x and y can change. So don't be intimidating. Don't be intimidated. Be intimidating. Stare people down. But don't let this scare you. Negative 2t plus 4. So then dy dx is going to be dy dt over dy dx is going to be dy dt over dx dt. So negative 2t plus 4 over 2. So negative t plus 2. Okay, let's move it and hope it fits. Yup. All right, path 3, I'm gonna do over here. So path, nope, you're not a marker. Path 3. Okay, we got dx dt is gonna be 12. dy dt, see what I mean? Just an excuse to do some derivatives. It's gonna be 12 pi sine of pi t. Because the derivative of cosine is negative sine and chain rule. And where did I get the 4? I think I just threw a 4 in there. That's not right. It's going to be pi. 3 pi sine of pi t. I've lost all of my confidence at this point, but I think that's right. And then dy dx is dy dt over dx dt, 3 pi sine of pi t over 12. So I guess 4, nope, pi sine pi t, yeah, over 4. Gross. All right, here we go. Let's move you. And I think, like, we weren't asked for any like keen insights or anything here. Just 3 paths going between 2 points. Looking at the rates of change, things like that. You can see, I mean, like, the x coordinate is definitely like booking it on this one, so it should take less time. And the y's are just, you know, this one is constant, this one's linear, and then this one's trig, so like you get a lot of change. All right, I'm gonna stop this here because we're at the end of the page, and I will see you in the next one.